Hello everyone. Our second experiment in DSA is implementation of QADT. A queue is a linear data structure that follows the FIFO, first in first out principle, meaning the first element inserted in the first one to be removed. It works much like a line of people waiting for service. The people who comes first get served first. The queue abstract data type defines key operations such as enqueue to insert an element at the rear, dequeue to remove an element from the front, peek is to view the front element without removing it, and is empty or full is full to check the queue status. These operations allow data to be processed in the same order in which it arrives. A queue can be implemented in two common ways. Using array or linked lists in the array-based implementation, two indices, front and rear, are used to keep track of the first and last elements. When an element is added, rear is incremented. When removed, front is incremented. This type of queue may lead to uh, unsent spaces after several insertions, solo insertions, and deletions, which can be resolved by using a circular queue where the last position connects back to the first in the linked list implementation. Each node contains data and pointer to the next node, allowing dynamic memory usage and avoiding overflow issues. Queue has widely applications in real-world and computing scenarios such as CPU scheduling, print spooling, uh, buffering in data transmissions, and breadth for search in graphs. Each operations like NQ and DQ has a constant time complexity, making queue efficient of managing ordered data. Overall, implementing a QADT provides a systematic way to handle tasks or data sequence in the order they are received, ensuring fairness and o- orderliness in processing. So there is an example code. In this, first we declare the queue declaration. Int queue size creates a fixed size queue. Then front is equals to -1, rear is equals to -1 indicates the queue is initially empty. Then menu driven structure uses do while loop with menu options for enqueue, dequeue, display, peek, and exit. User selects operations interactively. Enqueue operation. Enqueue operation means add elements at the rear of the queue, checks for overflow. If first insertion sets for front is equals to 0 and rear is equals to 0, otherwise increments rear and inserts the value. Then dequeue operation. Remove element from the front of the queue, checks for underflow, displays and increments front after deletion. Then display and peek operation. Display means prints elements from front to rear. Peek shows the front element without removing it. Then we can exit the program. Then I am selecting now NQ. NQ means entering the values into queue. So I inserted one value. Then I'm inserting another value. Then I'm inserting another value. So I entered three values. Now I am dequeuing one value. Dequeuing. Then 20 dequeued from the value because 20 was the first element I have entered. So now I am displaying which numbers are there. So only 30 is there. Then peak means it will show which is the last one. So the only one element is there. So absolutely 30 will only come. Then 5, I am exiting the code. Then the second experiment is also completed.